I thought I would go over a couple of problems from the Section 8.6 practice worksheet. This was the homework that you were assigned on Wednesday that was dealing with solving rational equations. So I was going to start with number 12, just so that you can kind of see the process of working through one of the problems. The directions for number 12, that group asked you to solve the equation by using the least common denominator. And then it specifically asked you to check for extraneous solutions. So if we look at the three fractions that we have in this problem, we see the denominator has an x minus 1. The second fraction is a 2. I'm just going to place that over 1. And then the last fraction is 1 over x. So the least common denominator, none of the denominators need factored, is just the list of the factors, or the denominators in this case. So one denominator is x, and the other denominator is x minus 1. That's going to be our least common denominator for this equation. So we're going to use that least common denominator and multiply the left side by the x and the x minus 1. And then doing the same thing with the right side, we're going to multiply that by x and x minus 1. So the goal when you're using equations is to apply the missing part to the numerator. So our current numerator says negative x plus 1. The denominator has an x minus 1. So for the least common denominator to be applied, that numerator needs the x. The next one is just the plus 2. It only has a 1. It does not contain any parts of the least common denominator, so it needs the x and the x minus 1. So that's going to become 2x times x minus 1. On the right side of the equation, we have an x, so it has that part of the common denominator. It's missing the x minus 1. So that's what my equation would look like. And now we're going to just solve this equation like we would have back in the first couple of chapters of the class. So see if you can work through and solve by distributing through and combining like terms. So after you combine like terms, our next step will be to set this equal to 0 because I see we have an x squared term and an x. And when we set it equal to 0, we get x squared minus 2x plus 1. So this is definitely factorable. It would factor as x minus 1 and x minus 1. They're the same quantity, so that's a perfect square. And if you solve, you get x equals positive 1. So it's just one solution there. But the directions, remember, asked you to check for extraneous solutions. An extraneous solution is an extra solution that does not work when you check it back into the original equation, or you substitute it into the original equation. And if we go back to that original equation and substitute the 1 in for the first fraction, I'm now replacing that 1 in the denominator for x, we end up with 1 minus 1, which gives us 0. We know with fractions that you cannot divide by 0. It gives us an undefined solution, which is how we get that vertical asymptote. So because when you plug 1 in, it makes the denominator 0, and this value at 1 is extraneous. So we would have a vertical asymptote when we were graphing these at the value of 1. So if the only solution we have is 1, and it's extraneous because it makes the first fraction undefined, that means there is no solution to this equation. Make sure that you cross off the answer because it does not work, and that you also state that it is no solution or has no solution because the only answer is the 1, and that does not work. So we're going to go over another problem, and I think we can look at number 15. So we have 4 over x minus 3, 2 over x plus 3, and then the other side we have a 2x plus 2, and that's over x squared minus 9. So the first problem we did, the denominators were already factored because there really wasn't any factoring to do with each of those. They were just a quantity of two terms, non-squared terms. In this case, if we look at the denominator on the right, that needs to be factored, and that factors as that sum and difference of squares. So it's the x plus 3 and the x minus 3, which is kind of nice that it factors like this because now we can think about that least common denominator being the x plus 3 and the x minus 3. Those are the two different factors that we see, or the two different denominators we see in this problem. So again, using the process we did above, multiplying the entire left part of the equation, both of those, by the least common denominator, and then multiplying the right by the least common denominator as well. And remember, we're applying the part that's missing to the numerator. So the first has the x minus 3, but it's missing the x plus 3. The second fraction has the x plus 3, it's missing the x minus 3, and it's a plus 2. Then we have our equal sign. And then on the other side, we have the x plus 3 and the x minus 3. It has the entire common denominator, so it needs nothing. It just stays as 2x plus 2. So that's what my next step would look like by applying the least common denominator, or that missing part, to the numerator. And now we have, again, an equation that we would have looked at multiple times throughout the year. We're trying to get x by itself. This one does not have a squared term, so that means we don't have to factor. Instead, we're just trying to solve for x, so take the x terms to one side, the numerical term to the other. And we end up with x equals 2. So before you move on to the next problem and you think you're done, make sure you check for extraneous solutions. So if we're looking for extraneous solutions, you're taking that 2 and plugging it into the denominator. So plugging it in first for the x minus 3. 2 minus 3 is negative 1. That's not 0. Plugging it into this second fraction. 2 plus 3 is 5, so that's good there as well. And then plugging it in for the last fraction. 2 squared minus 9 is negative 5. So it checks in each one of those. It doesn't give us a 0 or an undefined value. That means x equals 2 is our solution. So looking at one more, we'll complete number 18 together. If you find that you have other questions that I did not go over, please feel free to email me or ask the question in the next Zoom session. But number 18, we have an x, a 5 over x plus 6, and then that's equal to 6x minus 1 over x plus 6. I'm just going to place that 1 underneath the first x there. So this one's kind of nice. The least common denominator is just x plus 6. Using the same process, multiplying the left side of the equation by the least common denominator and the right side. And then thinking about what isn't missing. So our first denominator only has a 1. It's missing the x plus 6. So that becomes x times x plus 6. The second denominator has the x plus 6. It doesn't need anything, so the numerator is just that 5. On the other side of the equal sign, again, it has the x plus 6. It doesn't need anything. We just have the 6x minus 1. And now doing a little bit of algebra, foiling, distributing, and setting equal to 0. So we end up with x squared plus 6 equals 0, which if we continue to solve, taking the negative 6 to the other side, we take the square root of x squared to get x by itself, we end up with the square root of negative 6. Well, the square root of a negative number is an imaginary number, so that means there is no solution. We're only looking for the real solutions here. So you can't take the square root of a negative 6, that means we don't have a solution. So you got to see 3 different equations, solving those equations. I didn't go over anything from the first group, but the first group of problems there wanted you to still solve, but you're using the proportions, cross-multiplying. So make sure you're just taking the top left to the bottom right, and then the top right connects with the bottom left. You're doing a little bit of foiling there. Make sure you're watching your multiplication, and then setting it equal to 0 to solve. So if you do find that you have questions on anything else, again, send me an email or ask in the next Zoom session. Have a great day.